Hi, let's look at this indices question here. We are given that x to the power of half multiplied by x to the power of 1/3 is equals to 32. Alright, and we are supposed to find x. Let's see how we can approach this. For this first part of this expression here, we can apply the indices rule that says am multiplied by an, right, is equals to am plus n. So since we have both the bases to be the same, we add the power. So what I have here is x to the power of half plus 1/3 equals to 32. Half plus 1/3, okay, half plus 1/3, you need to uh, make them have a common denominator. So the common denominator can be 6. So here I will multiply by 3 by 3, and over here is by 2 by 2. So what I have here is 3 over 6 plus 2 over 6, which is 5 over 6. So let me write that here. X to the power of 5 over 6 equals to 32. Now, what is the next step? The next step is to see how I can represent 32 by a form that has a base and a power. Now, we can see that 32, alright, can actually be represented as 2 to the power of 5. Again, this kind of things will only come easy to you when you have a lot of practice. Alright, so the more practice you have, the more comfortable you are with numbers, you will be quite easily able to see, alright, how different numbers can be broken up into its representation in terms of base and power. Now coming back here, we can see that 32 is 2 to the power of 5. So let me write that first. X to the power of 5 over 6 is equals to 2 to the power of 5. Now, how do I solve this? Okay, moving forward from here. In order for me to solve for x, s is in this expression, x is in the base. Okay, so I need to move towards a point where on the left hand side I have a base a to the power of m equals to, on the right hand side, base to the power of n. Okay, when I have this, I can say that when both the bases are the same, it implies that both the powers are the same. So in our case, what we can do next is, since on the left hand side we have x to the power of 5 over 6, alright, and on the right hand side we have 2 to the power of 5. Okay, now let's see what we can do on the right hand side so that we can see that both the sides can have the same power. So originally I have 2 to the power of 5. Now if I want to have 5 over 6, that means if I take the power of 5 and I put a divide by 6 here, I can compensate it by doing a multiplication with 6. Alright, so on the right hand side, actually nothing has changed. I have done a divide by 6 and multiply by 6. Alright, now what can I see over here? Over on this right hand side here, what I have is 2 to the power of 5 over 6 times 6, which is actually 2 to the power of 5. Alright, so originally I have 2 to the power of 5 and nothing has changed. Alright, I'm only rewriting it in a different way. Now 5 over 6 times 6 or 6 times 5 over 6 is the same. Alright, so I can now rewrite it as 6 times 5 over 6. Okay, and based on indices rule, alright, which says that a to the power of m times n is equals to a to the power of m bracket n, and this is the same as writing it as a to the power of n bracket m. So whichever I write within a bracket and whichever I write outside the bracket doesn't matter, because both the powers that are inside and outside the bracket will both be multiplied by each other. That means that on this right hand side, I can now rewrite it as 2 to the power of 6 to the bracket of 5 over 6, alright, which is what I have here. And over on the left hand side, I can write what we already have, x to the power of 5 over 6. Now what do you see here? You see that the power over here and the power over here is now the same, which now means that both the bases are the same. So from this we can conclude that x is equals to 2 to the power of 6. So x is equals to 64. That is the final answer for this question here. Alright, so this question covers a few different rules of indices. As long as you're familiar with the rules and you know how to do some manipulation of the numbers, then it should be easy to understand how I approach this question here. Alright, thank you for watching. See you soon. Bye.